تنفذوا لا تنفذون إلا بسلطان.
Our universe might be like a slice of bread, just one slice, in a much larger loaf that physicists sometimes call the bulk. And if these ideas are right, the bulk may have other slices, other universes, that are right next to ours, in effect, parallel universes. Not only would our universe be nothing special, but we could have a lot of neighbors. Some of them could resemble our universe. They might have matter and planets and, who knows, maybe even beings of a sort. Others could certainly be a lot stranger. They might be ruled by completely different laws of physics. Now, all of these other universes would exist within the extra dimensions of M-theory, dimensions that are all around us. Some even say they might be right next to us, less than a millimeter away. But if that's true, why can't I see them or touch them?
If you have a brain living in a higher dimensional space and your particles, your atoms, cannot get off the brain, it's like trying to reach out, but you can't touch anything. It might as well be on the other end of the universe.
من عذاب الله أو تأتيهم الساعة بغتة وهم لا يشعرون.
It all has to do with shape. For years, we concentrated on strings that were closed loops, like rubber bands. But after M-theory, we turned our attention to other kinds. Now we think that everything we see around us, like matter and light, is made of open-ended strings. And the ends of each string are tied down to our three-dimensional membrane. But closed loops of string do exist. And one kind is responsible for gravity. It's called a graviton. With closed loops, there are no loose ends to tie down, so gravitons are free to escape into the other dimensions, diluting the strength of gravity and making it seem weaker than the other forces of nature. This suggests an intriguing possibility. If we do live on a membrane, and there are parallel universes on other membranes near us, we may never see them, but perhaps we could one day feel them through gravity.
أولم ير الذين كفروا أن السماوات والأرض كانتا رتقا ففتقناهما وجعلنا من الماء كل شيء حي أفلا يؤمنون.
As the classic story goes, the vast universe we see today was once extremely small, unimaginably small. Then, suddenly, it got bigger. A lot bigger during the dramatic event known as the Big Bang. The Big Bang stretched the fabric of space and set off the chain of events that brought us to the universe we know and love today.
والسماء بنيناها بأيد وإنا لموسعون.
And on top of this, there's the bang itself. What exactly is that?
That's actually a problem. Classic form of the Big Bang Theory really says nothing about what banged, what happened before it banged, or what caused it to bang.
Refinements to the Big Bang Theory do suggest explanations for the bang, but none of them turn the clock back completely to the moment when everything started.
Most people come at this with the naive notion that there was a beginning, that somehow space and time emerged from nothingness into somethingness.
Well, I don't know about you, but I don't like nothing.
بسم الله الرحمن الرحيم والسماء والطارق وما أدراك ما الطارق النجم الثاقب إن كل نفس لما عليها حافظ.
Do I really believe that the universe was a big bang out of nothing?
Everyone admits there are problems. The question is, can string theory solve them? Some string theorists have suggested that the Big Bang wasn't the beginning at all, that the universe could have existed long before, even forever.
هل أتى على الإنسان حين من الدهر لم يكن شيئا مذكورا.
This is Fermilab, and right now it's our best hope for proving that extra dimensions are real. Fermilab has a giant atom smasher. Here's how it works. Scientists zap hydrogen atoms with huge amounts of electricity. Later, they strip them of their electrons and send the protons zooming around a 4-mile circular tunnel beneath the prairie. Just as they're approaching the speed of light, they're steered into collisions with particles whizzing in the opposite direction. Most collisions are just glancing blows, but occasionally there's a direct hit. The result is a shower of unusual subatomic particles. The hope is that among these particles will be a tiny unit of gravity, the graviton. Gravitons, according to string theory, are closed loops, so they can float off into the extra dimensions. The grand prize would be a snapshot of a graviton at the moment of escape.
And then the graviton goes to the extra dimension, and then it shows in the detector by its absence. You see it by its absence.
وما تكون في شأن وما تتلو منه من قرآن ولا تعملون من عمل إلا كنا عليكم شهودا إذ تفيضون فيه وما يعزب عن ربك من مثقال ذرة في الأرض ولا في السماء ولا أصغر من ذلك ولا أكبر إلا في كتاب